Welcome. So in these next two examples, we're going to factor out variables with fractional exponents. This type of factoring occurs in calculus, so you're learning something for calculus next year. All right, so one rule of factoring out a greatest common factor is you can only factor out the smallest exponent you have. So if we look at our first equation or expression here, 3x to the 3 halves minus 9x to the 1 half plus 6x to the negative 1 half, right? Well, 3 halves, that's greater than 1 half. And 1 half is greater than negative 1 half. So x to the negative 1 half is our smallest factor of x, the smallest exponent that we can factor out. Right? So we can't factor out anything greater than x to the negative 1 half because that's all that last one has. Right? The other two exponents are larger. Now we also see that the coefficients have a greatest common factor. 3, 6, 9, they're all divisible by 3. So the greatest common factor is 3x to the negative 1 half. Right, and we're going to divide each of these terms in the expression by 3x to the negative 1 half. I'm actually going to write out the subtraction for the division. Right, remember we subtract exponents to divide like bases raised to a power, because I think it will be easier for you to follow along and you'll be less likely to make mistakes. I suggest that when you are factoring a fractional exponent, that you also write what you're subtracting. So in other words, we're going to subtract a negative 1 half from each of our factors of x. Right? We can just do the division for the coefficients in our head, but I think it will be very helpful to actually write down what we're doing for the factors of x. So 3 divided by 3, that's 1. X to the 3 halves divided by x to the negative 1 half would be x to the 3 halves minus negative 1 half. Right? We're subtracting the exponents to divide. And I'm just going to go right across and take over the space for b, and we'll just do b below. Right? And then we have minus, so 9 divided by 3 would be 3. And then we have x to the 1 half minus negative 1 half, right? So to divide like bases raised to a power, we subtract the exponents. And then 6 divided by 3 is 2. And then we have 2x to the negative 1 half minus a negative 1 half. All right, now we're just going to simplify. So we have 3x to the negative 1 half times, all right, so 3 halves minus a negative 1 half, that's the same as 3 halves plus 1 half. 3 halves plus 1 half is 4 halves, right? So I just 3 halves plus 1 half is 4 halves, and that's just 2. All right, so this is going to be x squared. And then we have 1 half minus a negative 1 half is the same as 1 half plus 1 half. Well, that's just 1. So this would be minus 3. And then we have negative 1 half plus 1 half. Well, that's just 1. All right, so this would be, that's just 0. And so this would be, oops, we lost an x there. And that would just be plus 2. Well, haven't we seen that expression before? Let's just see. Let's just go back here and see if we've seen it somewhere before in a previous video. So let's see. X squared minus 2x minus 3. And that's just right back up to where we were. This one's x squared, I'm sorry, this one's x squared minus 3x plus 2. Very, very close. All right, we could factor that, though, in any case. All right, you might see what it was going to factor to, but let's just do factor by grouping in case you don't. All right, so we still have this term here. And so x squared minus 3x plus 2 multiplies to give us 2, adds to give us negative 3. All right, well, that's going to be negative 2 and negative 1. And it doesn't matter who goes where. So we have x squared minus 2x plus a negative x plus 2. We've just replaced the negative 3x. The first two are a group, the second two are a group, and we can plot a greatest common factor. So we can pull out an x from x squared minus 2, and if we divide that, we would have x minus 2. We can factor out a negative 1, and that's just going to change the signs of those terms to x minus 2. We can factor out that repeating x minus 2. We're left with an x minus 1, and don't forget, the very first thing we factored out was a 3x to the negative 1/2. And there we go. So you might not have thought you could factor 3x to the 3/2 minus 9x to the 1/2 plus 6x to the negative 1/2. But using the tools that you've learned, factoring out a greatest common factor, factored by grouping for quadratics, it wasn't too hard, now was it? Right? We have it all figured out. I'm going to have to get a second slide to do the second problem because I took up too much space. But that's okay, we needed this space. And if you have questions, let me know in case I go too fast. Oops, let's see if we could, there, almost. No, I don't want to insert a page. Smartboard doesn't like me doing that when we are filming. So I will walk over to the computer and I will clone the page. And there we go. We'll just go to the next page, which is cloned. And we'll erase this because we're going to do the second problem. Boop. All gone. All right. So now our greatest, so we're doing the second one, our greatest common factor. Well, you see we have 2 plus x. But you can only factor out the smallest value. We've got a negative 2/3, and we've got a 1/3 who's smaller. Well, I hope you said negative 2/3. That is a smaller number. It's negative. It must be smaller. All right, so we're going to factor out 2 plus x to the negative 2/3. All right, so we have 2 plus x to the negative 2/3. And if we divide 2 plus x to the negative 2/3, actually, you know what, I'll write it all out. So if when we're dividing, remember we subtract exponents. So this would be 2 plus x to the negative, oops, up into my 2. So this is going to be to the negative 2/3 minus a negative 2/3 power. And then we had an x in there, times x. We'll put brackets. And then plus 2 plus x to the 1/3 power minus negative 2/3, right? If we're factoring out 2 plus x to the negative 2/3 power, we're going to subtract the exponents of those like bases of that 2 plus x, right? So now let's simplify. We've got 2 plus x to the negative 2/3 power. Now negative 2/3 plus 2/3, this is going to be 0, right? So that's just going to be, anything to the 0 power, right, is just 1. So this is just going to be an x. All right, now we have 1/3 minus a negative 2/3. That's the same as 1/3 plus 2/3, and that's going to be 1. So this is going to be, we have an x plus 2 plus x, right, because this is to the first power. And we don't really need to put into the first power because 2 plus x to the first power is just 2 plus x. So there's not going to be any additional factoring here, but we can combine the like terms. So we have, and actually I'm going to, I'll leave it like this, 2 plus x. But I'm going to put, on the second expression, I'm going to put the terms in the same order. In other words, I'm going to put the constant first. So we have 2 plus x to the negative 2/3 power times, we've got 2 x's, sorry. I thought for a second there we were going to have an x plus 2 again. We have a 2x plus 2. So it doesn't matter if it was a 2 plus 2x. If it had been another 2 plus x, I would have been like, huh? We could combine them. Right? And that's all there is to that one. Right? So it looks tricky at first, right? But just remember, you can only factor out the smallest to the smallest exponent, and then when you're factoring, when you're dividing, just remember to subtract exponents of like bases to divide. And whoops. So I guess did I have 2 of them? Maybe I made 2. Oh, I guess I made 2 of them. I guess I did clone this page. I'll get rid of it because we don't need it. But we're going to go on to the next one, the last problem. And this is super easy. This is just factor by grouping for polynomials. So polynomials with at least 4 terms can sometimes be factored by grouping terms. Right? Let's do these two. So to use factor by grouping, you don't even have to think of what multiplies to equal this and adds to equal b, because you've got all the terms you need. The first 2 are a group, the second 2 are a group. All right, if it works, you're going to get a common binomial. If you don't get a common binomial, it didn't work. All right, so we're going to factor out the greatest common factor for x cubed and x squared, and that would be x squared. X cubed divided by x squared is x. X squared divided by itself is just 1. 4x and 4 are both divisible by 4. 4x divided by 4 is x, and 4 divided by itself is 1. And we can factor out that repeating x plus 1, and we're left with x squared plus 4. All right, now that doesn't technically factor anymore, right? Because it is not a difference of squares, it's a sum of squares. So we're done with that one. Let's do the next one. All right, so the first 2 are a group. X cubed minus 2x squared. Don't forget to put a plus and make the negative goes with the 9. So the second 2 are a group. Negative 9x plus 18. Factor out our greatest common factor. They're both divisible by x squared. X cubed divided by x squared is x. Negative 2x squared divided by x squared is 2. Negative 9x and 18 are divisible by 9 because we want a common factor here, a common binomial. And to get a common binomial, got to have the same sign at least, right? Negative 9x divided by negative 9 is going to be an x, and 18 divided by negative 9 is a positive 2. And we can factor out the x minus 2. And we're left with the repeating x squared minus 9. Now that can be factored because it's a difference of squares. So we're going to have square root minus square root and square root plus square root. And there we go. That's all done. All right, so just reviewing a little bit of factor with grouping for polynomials and using what you've learned in terms of factoring out a common binomial and factor by grouping with fractional exponents, rational exponents. All right, thanks for watching. Bye for now.